Hello,
Hello.
and good afternoon, everyone. I'm Aniket, and on behalf of Godrej Material Handling, I welcome you all to our next and 35th webinar of from our Godrej Storage and Handling Knowledge Series titled Advanced Storage System, a safe and dense high throughput storage system through FIFO operations. Before I move on to introduce our esteemed speaker for today, just let me revisit the core purpose of running this knowledge sharing platform that is built specifically for the intralogistics domain. I would say it's a Godrej's way to giving back to the society and the industry the knowledge that we have gathered in the past 6 decades now. So we are very glad to be running this series, and I'm happy to express that time and again the encouragement for continuing this that has always increased and we have always received overwhelming response from you all. So coming to today's topic, in I think in today's rapidly evolving uh, in today's rapidly evolving technological landscape, the need for efficient and reliable storage solution has never been more critical. This webinar aims to enlighten our audience on the latest breakthrough in storage technology, specifically focusing on a system that offers exceptional performance, safety, density, and FIFO operation. So FIFO is nothing but first in, first out operation support. So during this engaging session, our team of industry experts will provide a comprehensive overview of storage systems and delve into the features and benefits of the innovative, safe and dense high throughput storage system supporting FIFO operations. We will explore the challenges faced by traditional storage systems and how this cutting edge system addresses them, revolutionizing the way data is stored, accessed and managed. So I think by the end of this webinar, you will have a comprehensive understanding of the challenges faced by traditional storage systems and the remarkable potential of a safe and dense high throughput storage system. You will gain insights into how this innovative solution can enhance data management, improve performance, and even open new possibilities for various industries. So I'm sure that this is going to be a very engaging and a very knowledgeable session. Coming to our eminent speaker for today, we are delighted to have Mr. Shiva, who is the Associate General Manager and Head of Marketing at Godrej Storage Solutions. Mr. Shiva is a chemical engineer with Masters in Marketing Management. He has been in sales and marketing profiles for over 2 decades now with Godrej and Boyce. His current assignment is to create integrated marketing strategy to provide best in-class customer experience to the customers of Godrej Storage Solutions. I welcome Shiva sir. Before I move on, I would request everyone to put in their questions in the chat box on the top right of your screen. We shall try to answer them at the end of the session. If time permits, we'll take all the questions. If we miss out on few questions, don't worry, we'll be taking them offline. We'll be replying to your questions offline as well. Please don't forget to write your name in the Q&A box when you mention your question so that we can get back to you in case we miss your question during the webinar. With that, I request Mr. Shiva to take over and I wish everyone has an insightful session. Mr. Shiva, over to you, sir. Shiva, sir,
So
you're
you are
on
on mute.
mute.
Yes, you may proceed.
Yeah. Very good afternoon to all our viewers, and a warm welcome to this webinar. Thank you for sparing your very valuable time to attend this webinar. I hope at the end of the session, we all go with quite a bit of information on this webinar. Thank you once again, and let me start. Um, the webinar is on a safe and dense high storage system which gives a high throughput and supports FIFO operations. Yeah. So the contents of the webinar is we will talk about warehouse operations, storage applications, storage solutions, and the specific point where we delve into the specific storage or which gives a safe, denser storage and gives a higher throughput compared to static storage systems, and which also supports first in, first out operation along with last in, first out operation too. Then we will go on to the system detailing, its features and its applications, and then do some comparisons to see how this is better over another system, which is also a denser system. Yeah. So to start with, how do we define a warehouse? A warehouse is a place or a space where goods are stored, normally in large quantities, right? Like what we see in the picture. And why do we need a storage system? For ease of accessibility, to have a organized storage, to have safe storage of goods, and to ensure security so that no pilferage happens. Through this, what do we ensure? We ensure quality of goods without any damages or any negative effect on the products. We ensure that the products reach our customers, be it internal or external customers, within the time which they require, and hence you require a storage system to ensure that the materials are stored in good condition in a proper way. So how does it happen? How does a warehouse assist in meeting the customer's requirement? What we talked about, we will see a small supply chain diagram wherein it explains. Let me take you through the diagram. You have, where my pointer is there, you have our raw materials coming. It's a typical, this supply chain diagram is typically a manufacturing led organizations depiction. So you have a raw materials coming in. Raw materials get stored in a warehouse, and from warehouse it moves to the factory. Either you have a separate warehouse, or we have sometimes a factory attached to warehouse where the raw materials are stored. From there, you get the finished goods after the raw materials gets processed, gets on to distribution center, goes on to the customer point, to the stores, end stores, where the customer comes and picks up the material, whatever he or she wants. This is one scenario. Another scenario could be you have the raw materials going directly to the factory. It could be a factory attached warehouse, or it could be directly getting into the production cycle. And then the finished goods is getting into a warehouse. From the warehouse, it gets distributed to various distribution centers and then moves on to customer points where the customer picks up. All through the process, there is quite a lot of information which is managed in terms of the material availability, the real-time inventory, what is available, and how fast it can reach the customer's place. And you have the entire intralogistics operations happening this way, with a fleet of transportation assisting materials to move from raw materials till the finished goods until to the final end customer. Yeah. So this picture shows how imminent it is to have a warehouse, and it shows that efficient warehouse is most critical for the customer to have the product in time and also in good condition. Moving on to the applications, we saw how a storage assists in ensuring the products reaching the customers. Now moving on to various applications where the storage can be used, or where storages are used. Raw materials usually are used in production environment, where you store it in lots in the storage area. And it's also used, storage systems are also used for assembly purposes, where the raw materials or parts which are stored in racking systems or in shelving systems, which are used to further process and or to further get assembled to become a finished good so that it can reach the end customer. Packaging material is one more thing for which warehouses are maintained. Here you have a primary packed material which is there. It could get on to bulk packing through secondary and tertiary packing. So the packaging material also needs to be stored in a warehousing environment in in warehouses in a manufacturing environment, which becomes critical for packing and ensuring that it is dispatched to either the distribution centers or to the warehouses where it is being stocked, from where it can move on to distribution center and to the final customer. Finished goods are stored in factory attached warehouses and also in distribution centers, as we saw in the supply chain diagram. So these are the two areas where it can be stored. Distribution centers offer much more value-added activities further in terms of distributing it to the final end customer by kitting the products, making the products as per the order required, typically in organizations like e-commerce industry, in an e-commerce organization. Yeah, so you have warehouses attached to factory, as well as the warehouses which are acting as distribution centers where finished goods are stored. These are some of the storage applications. More storages also do happen in the factories where you have maintenance stores, where the materials are the part materials are stored in bins in shelving system, or if the sizes are larger, it is stored in the racking system too. Furthermore, in terms of documents, typical record management systems or any large document storage areas are also there where you require storage system. It could be dense or it could be stored in terms of in a racking system where storage later on need to be retrieved. The stored documents need to be retrieved for usage. So storage is used for storing the documents too. So these are some of the applications where materials are stored. So storage is required for any type of materials to be stored, from raw material to finished goods to whatever we saw, so that the end customer can be served with the product as and when they require. Coming on to the types of storage solutions, largely it is divided into two: racking and shelving system. Racking systems are used for bulk storages, wherein materials are stored or retrieved using material handling equipment. And shelving is usually for discrete picking and storing of materials, where usually people handle the material with smaller trolleys to stack and to shelve or to retrieve. So these are the two major product classifications where the storage solutions are provided. There's a racking and shelving. Coming on to detailing in racking, in case of selective and non-dense racking system, the preferred solutions are selective pallet tracking, wherein you have 100% selectivity, and the selection is done through the aisles through which the material handling equipment can get inside to the racking area and select the pallet, the material which is required. You also have high bay racking, which goes taller. You also have double deep racking, a double deep selective pallet tracking. The difference between double deep and the selective pallet tracking is that selective pallet tracking is single deep and double deep pallet tracking is double the deep compared to a selective pallet tracking. So here there are quite a lot of bays in between the racking system to ensure that selectivity happens, and hence it becomes a non-dense system, but selectivity is very high. In terms of selective as well as dense, you have something called a mobile pallet tracking, where the racking system is housed on a carriage and the carriage moves on rails. So with one aisle, that aisle can be made to move between the racking positions by moving the entire understructure. So the racking system is designed in such a way that only one aisle is permanently available. And when you need to retrieve any other pallet in any of the other racking system where the aisle is not there, there an aisle is created by the entire undercarriage moving in the area of aisle, and then a new aisle is getting created. So the concept is that the entire racking system moves over rails, and wherever it is required, the aisle is created, and the material handling equipment could get inside and access the particular pallet and take out the material. Automated storage and retrieval system is assisted through crane picking, and it's also a dense system for picking and sorting, which could also be integrated with warehouse management system for real-time monitoring of stock availabilities. Coming to dense and limited selectivity, you have drive-in racking, where the material handling equipment gets driven inside the racking system to store or to retrieve the material. Select shuttle racking is the one which is an advancement over the drive-in racking, and this is the one which we are going to delve deep into today to see how it assesses better selectivity and better variety compared to the drive-in racking. And you have pallet flow racking, which is a completely first in, first out system, wherein at one end of the racking system, the material is loaded, and through gravity, through the rollers, the material flows to the other end. And at the other end, the material can be retrieved. So one end is used for loading and another end for unloading. So this is a perfect example of first in, first out. And pushback racking is a example, is a racking system which will facilitate last in, first out. Here we could go up to 4 or max 5 deep, to the extent that the material are pushed inside the racking system and the last material is first retrieved. So pushback is a last in, first out, and pallet flow is a first in, first out. If both need to be done, then shuttle racking is the solution what we have. And that's what we are going to see in detail today. So this sums up the more or less the broad classification of racking and the details of what solutions are available in racking system. Coming to the next product category of shelving, we have selective and non-dense shelving system, which is boltless shelving system, longer span shelving for longer products, heavier duty shelving system to store materials which have higher weight uh, uh, than the ones which can be stored in a boltless shelving system, which is for a lesser weight shelving system. It's a lighter duty shelving system. And you've got mezzanine system also, which is a part of shelving system, where you can do a lot of value add activities like bundling or bundling the products, or doing kitting operations, or any other value adds like barcoding and so on. So this is on the selective and non-dense shelving system. And for dense shelving, we have the mobile system. It compacts itself one body over the other, and hence it becomes a pretty dense system. And with the limited aisle movement, we can alter the rails between individual bodies and create aisles and access the materials which is stored inside these shelves within the mobile system. So this sums up the shelving products. Now we will get into the solutions of racking as we are going to go deeper into the shuttle pallet racking to see how it offers advantages over other static racking system. The first static racking system is the selective pallet racking. This assesses 100% selectivity, because there is an aisle between each racking system, which will assist material handling equipment to move inside and access any of the rack positions, and remove or to store the pallets, and hence it offers 100% selectivity. It's compatible with the material handling equipment suitable to the aisle width. So here, this particular picture shows wide wide aisle racking system. You could have a narrower aisle racking and a very narrow aisle racking system also, where the aisle space width gets reduced and because of which the density of the racking system gets increased, and hence the cubic space utilization increases from 18% to 28% as we move from wide aisle racking system to very narrow aisle racking system. Coming to double deep racking system, this offers 50% selectivity. Why 50%? Because as you see in this picture where my cursor is there, you have two deeps, and if the second deep pallet has to be accessed, the first one has to be actually removed out, and hence you have only 50% selectivity. So this supports where the variety is a little lesser than the selective pallet tracking, because if you have a variety in this position and another variety in this position, to access the inner pallet, the outer pallet has to be removed. So ideally, if these two pallet positions are going to be of same SKU, then it helps. So hence it's 50% selectivity. The capacity increases by 33% compared to a selective pallet tracking, which we saw in the previous slide. And special double deep reach truck is required so that this pallet positions in the inner deep point of the racking system is accessible. And it is suitable where there are more pallets of the same SKUs to be stored, as I mentioned. So the two deeps with same SKU will help good utilization of this racking structure. Skilled operator is very much required because the material handling equipment which will be operating this racking structure need to get inside to the second deep to handle the pallet, and hence there is more skill required to carefully take the double deep reach truck's arm inside the racking structure so that without touching onto the racking system or without damaging the racking system, and hence skills required. Relatively a time consuming operation once you have to take this product from the deeper part of the racking structure, and hence it offers a lower throughput compared to a selective racking system, and hence it's a little time consuming. Coming to pushback racking, here as I mentioned earlier, 4 to 5 pushback can be done, and it is dense to that extent with limited selectivity, because in one bay it has to be only one product variety which can be put in, because unless and otherwise the last product is taken out, the inner product cannot be taken out, and hence the same variety has to be stacked in one bay. Pallets are stored by pushing back the existing pallet in the storage system, which is outside, and most of the MHEs can be used for storing and retrieving. Coming to the next one, the drive-in racking. Drive-in racking is a dense storage system with reduced selectivity. Why reduced selectivity? Because in this picture, if you see the drive-in system, that is the material handling equipment can get inside the system, go through and through inside the system, and stack the products at different levels or retrieve the products at different level and bring it out. So the thing is that across the bay, across the levels in a bay rather, only one variety can be stored so that it can be retrieved, or it can be retrieved as and when required by the material handling equipment operator. If there are different SKUs or different variety of products stored at different levels, then it becomes difficult to access the inner stored variety unless and otherwise the outer material are removed. Hence, we need to have one variety stored across levels in one bay. Here the MHE goes inside the system to access the pallet positions. Operational efficiency decreases because material handling equipment has to travel inside the storage system very carefully without damaging the storage system itself. So having seen these racking systems, which are static racking systems, if we require more selectivity, denser storage, and a safer system without need to worry if the material handling equipment will damage the storage system, And if we need to support a first in, first out as well as a higher throughput, then the answer is a shuttle racking system. And here, this is the racking system in which the shuttle operates, which you can see over here, 4 shuttles placed. And this is the shuttle equipment. Shuttle equipment takes the material or the pallet in which the materials are loaded and moves inside the racking system and places wherever it is required, or retrieves the pallet from wherever it is placed and brings it to home position, which is the outside position. And shuttle is best suited when dense and deep lane storage is required. The depth of the lane can be 10 pallet positions or 20 or 30, 50 like that. It can go as much as required. We have given even 60, 70 pallet deep racking systems. So to that extent, we can have a denser system. Spaces, and where there is a spaces where space is a constraint. In today's scenario, space is very costlier in Indian scenario. So space is a constraint and it's very expensive, and hence if you want to have a denser system, this is one such system which becomes very economical to operate, and also offers selectivity too. How selectivity? Because here we can have the shuttle over in this level, or if the shuttle is required at this level, we can have a shuttle at this level, or at any level across the bay, we can have the shuttle. Just the shuttle needs to be picked up by the material handling equipment. It needs to be placed in the bay in the level wherever it is required, and then the shuttle can be operated along that bay in that level. So it can go inside that level in that particular bay. Whenever it has to be shifted to another bay, the material handling equipment has to come over and access the shuttle at the home position, pick it up and put it in whichever bay, in whichever level it is required to operate, to move the products to store or to retrieve. So it can be used in temperature controlled cold storage area. It can go up to 50 degrees in plus 50 degree to minus 35 degrees. That is the type of temperatures in which the shuttle can operate. Higher throughput compared to static systems, because the speed of operation could be is much higher than the at least compared to the earlier system what we saw, which was a driving system wherein the material handling equipment needs to drive inside the tracking system to access the material and carefully bring it out if it has to be retrieved, or to carefully store inside when it gets into. So that much of time consumption doesn't happen when a shuttle has to pick up a material from inside and bring it out, or to store a material inside a place inside the bay wherever it has to be stored. So the throughput is much higher than the driving system. Here, the typical usage of this system is when you have a lesser variety, not for a larger variety. When larger variety, we need to go for systems like selective pallet tracking. A lesser variety, but a larger lots of material to be stored. This is the best system which we can go with, and safer operations, because the material handling equipment goes only till this point, which is outside the entire racking system, and any access inside the racking system is done by the shuttle equipment. And it completely supports first in, first out, because in case first in, first out is required, the other end of the system can be kept open, and as and when it is stored at the other end of the bay, the retrieval can also happen from the other end, and hence it completely supports first in, first out, and even last in, first out also is supported by the system. Coming to cubic space utilization, having seen these racking structures, um, the first three what you are able to see on the screen are selective pallet tracking material, selective pallet tracking solutions rather, with wide aisle racking, narrow aisle racking, and very narrow aisle racking. So the cubic space increases as the aisle gets narrower, and hence more denser storages. Double deep pallet racking also is equivalent to a very narrow aisle racking. The pushback racking offers a little more denser, but the pushback would be to the extent of only 4 to 5 deep. Drive-in, which we saw a few slides before, offers a larger cubic space utilization of the warehouse, which is 43%. And once you come to a shuttle, the shuttle also offers 43%, which is equal to a drive-in, but it offers FIFO operations in a better way. It offers larger variety, which we will see in the slides to come. So with larger variety, with FIFO operation, and without the material handling equipment to go inside the drive-in, a safer solution as well as a quicker throughput. So shuttle offers a lot more compared to a drive-in, which is a denser system. So same dense cubic space utilization, but far more efficient system is a shuttle system. So this is the inner view of the shuttle racking system, and you could see the channels through which a shuttle would be traveling into the shuttle into the inside the bay. A broader level components, you've got a frame assembly, a beam assembly on which the pallet rail or the shuttle rail is placed. Shuttle rail is something like this, and you have a pallet guide at every level at the home position to guide the shuttle to be placed, and you have got entry support for the shuttle to be placed inside the level. And with the material handling equipment, once a shuttle is placed in one level in a bay, then the shuttle can be operated with the help of remote control to store or retrieve the material as and when required. Applications across industry, the applications of shuttle pallet tracking is there in terms of food and beverages, chemicals, healthcare, FMCG, consumer durables, in cold store industry. Not only that, even in engineering and manufacturing sectors too, it is applicable. Across sectors, we've tried to map the applications in terms of how the storing and picking of raw material, packaging material, and finished goods is done or is happening, and how distribution is assisted across the industry sectors. So in terms of raw material, in FMCG, food and beverages, pharma, healthcare, consumer durables, engineering, everywhere we have the raw materials coming inside, getting processed, and packaging happens across these industries. Not much in engineering, very minimal packaging happens, and hence packing material is very less in the engineering sector. Now, finished goods, yes, all these sectors roll out the finished goods, which needs storage applications, and then gets on to the distribution centers from where it goes to the end customer. Here, the 3PL, third-party logistics organizations, and retail and e-com industries to contribute to the distribution center storage areas. Coming to the type of SKUs, all SKUs go with it in terms of storing in a shuttle racking, using a shuttle racking system across the industry segments. These are some of the examples what are given on the pictures. They are bundled properly so that it can be housed nicely inside a pallet, and the pallet can be accessed through the shuttle. The shuttle can house these pallets and pick up the pallet and place at the positions wherever required or retrieve from wherever it is required. We'll come to the functions of the shuttle system. There are certain standard functions and there are a lot of optional features also available in a shuttle racking system. Primarily, the storage happens using the shuttle on the racking structure. So critical for us to understand the functions of the shuttle, which will enable us to store the material on the racking structure in a safe and good way so that the quality of material and the state of the material, whatever we are storing, will be as it is stored. Starting with the standard feature, we'll start with the loading. So you could see the shuttle being placed on the rail by the material handling equipment, and the material handling operator places the pallet on the shuttle. And then once the load function is clicked on the remote control through which the shuttle is operated, the shuttle picks the pallet, lifts it up, and transports it to the position whichever is available. So here honeycombing doesn't happen, in the sense that you don't have any vacant spaces getting created. So to that extent, excuse me, to that extent, a denser storage happens, and then the shuttle returns back to the home. Here the unloading is happening in a similar way. So in terms of continuous picking and storage, that's also possible through continuous picking option. With continuous picking, the shuttle moves and comes and picks up as and when the storage is storing is done on the home position by the material handling equipment. And similarly, it happens for picking too. So distance between pallets are also ensured in case there's a pallet overflow. What do we mean by pallet overflow? In case the products which we store is slightly bulkier than the pallet size and it overflows the pallet dimensions, then a space need to be given between the pallets. So that distance between pallet can be managed to get automatically set by the in the shuttle itself, thereby ensuring the quality of goods whatever we store. Coming to these are some of the standard features. Coming to the optional functions, optional functions such as there are various optional functions. We'll go through the major ones. We could have a compacting push. What do we mean by compacting push? Once compacting push is activated, then the shuttle ensures that the entire material which is loaded by material handling equipment gets compacted and pushed to the other end, so that the first in material can be first out when the loading has to happen. So the entire material is pushed to the end, and as and when the unloading happens, then the next material comes to the home position. Once that is also taken out and unloaded, the third one comes to the home position. That way the entire material gets compacted at the home position so that entire material can be unloaded. This is the compacting push, which assists first in, first out. Compacting pull happens in last in, first out. So once the material is taken out from the home position by the material handling equipment, the shuttle ensures that the next pallet is pulled. So similarly, all the pallets are pulled to the home position till whatever the material is available in that level in that bay is completely taken off. These are compacting push and pull. Anti-collision functions can also be enabled when two shuttles have to be made to operate on a in a level wherein you need first in, first out as well, wherein you need to at one end keep loading the material and other end need to take away the material. Counting of the pallets can be done in a shuttle when the lanes are longer. So there is a provision to note how many pallets have been stacked, and that pallets can be counted using this provision. Multiple deep pallets can also be managed using the shuttle. So there is an option to provide to identify multiple deep pallet and pick it or to place wherever it is required. There is one more option of continuous plus picking, which ensures that once a picking operation is done, and the next pallet will be in queue. Once one pallet is unloaded, then the next one in queue comes to the home position. Once that is unloaded, the next one will be in queue. So in continuous plus, permanently one pallet will be in queue so that it can occupy the home position by the time the home position pallet is picked up and unloaded. Distance between pallets, we talked previously about overflow. Distance between pallets can be increased to go up to 350 millimeters of distance between the pallet positions. So these are some of the optional features which are available. Coming to overall shuttle overview of a shuttle, what it offers, it's suitable for industry where it's the pallet sizes are standard. Maximum load carrying capacity is 150 kilogram. Uniform distributed load. Optionally 2000, it can go up to 2000 kilogram. The movement speed of the shuttle is 35 meter per minute in loaded condition and 70 meter per minute in empty conditions. Shuttle movement is activated by the remote controller, which can be operated by the operator who is wanting to store or retrieve the material. Optional functions, whichever we went through, increases the operating efficiency. Thereby, other features can be enabled, and it's completely battery operated. Components. You've got a Ethernet connection communication port where the shuttle can be programmed or it needs to be reset for various operations other than even some of the major operational features we saw. Sometimes if you require to slow down the speed of the shuttle in light of transporting some oil tins or something, so those things, those programming can be done using this Ethernet communication port. Unit identification number is a number individual for a shuttle system so that a remote can locate different shuttles with different identification number. The same remote can be used for different shuttles, and hence the identification number becomes very critical. Anti-dust sensor, once dust gets accumulated, message goes on to the remote controller. Thereby the dust sensor can be cleaned. During operations, usually dust get accumulated, and this cleaning operation ensures that the inner life of the components, electronic components, say the shuttle system remains good. You have a battery. Hoisting profiles are the ones which ensure that the the pallet and the material are picked up, it is pushed upwards and then transported to store or to retrieve. You have got a remote controller. Automatic hookup with AutoSat is a provision where the shuttle can be latched on in case you need to service the shuttle. It can be brought to the home position if it's not functioning or something. So this is to transport the shuttle to service it up. Auto service can also be used. A person can get onto it, hand operate, go onto use the rail where the shuttle is operating. In that rail itself, this can be moved, then get near to the shuttle which is not operating properly and hook it up using this automatic hookup and then bring it to the home position and then take it out with the help of material handling equipment. Magnetic safety plates are the ones which are underneath the shuttle to ensure that the shuttle can be picked up by a material handling equipment and put up at the level in the bay wherever required with ease so that it doesn't slip from the material handling equipment forearms. So you've got optical sensor to sense sense the home position place so that it can stop. Flash LED is to identify the shuttle. Emergency button is to stop the shuttle whenever required. And safety bumper to ensure that it doesn't bang on any material which is it just slipped off from the place, so that it smoothly touches, and then it's a safety accessory for the shuttle. So these are some of the components of the shuttle for you to understand how it operates and how these are of use to the storing and retrieving of products. Metal handling equipment, reach truck and forklifts are the best suited ones to be used in a shuttle racking system. Some of the installation references: heavy machine parts stored in a shuttle racking. Beverage industry, where bottles are being stored on the racking system. In the food industry, where again packs are being stored. This was done for retail industry. Okay, excuse me. Yeah. Now we'll do a small comparison between shuttle and drive-in. We said that shuttle is a far more efficient system compared to a drive-in system. We will go through it to see how it is. So on the left-hand side, you can see a drive-in pallet racking, and the right-hand side, you have a shuttle pallet racking. As explained earlier, in drive-in pallet racking, the material handling equipment can go through and through, and in shuttle system, the shuttle takes the material inside or retrieves and comes out. We'll go through some of the differences to understand how it services the customer needs and expectations. To store multiple varieties, each level can have different varieties as far as shuttle racking is concerned, which would not be possible in a drive-in racking, because in one bay we can have only one product, but in shuttle racking, it is possible to have in one bay different products across levels. Let me explain through this picture. Actually, this is a shuttle system, but let me explain it to you. Let me use this to explain you how it behaves in a drive-in system. In a drive-in typical system, this entire bay, which is with this yellow mark, has to be with one particular product category, one particular SKU only. Multiple quantities can be stored, but for the ease of retrieval and to stack, in case anything is stored of different category, then to retrieve that product, the other products which is outside has to be retrieved. So it will not be possible for us to store different products in one bay across levels. Whereas in a shuttle racking, we can have different products across different levels in quantities, because a shuttle can access each level independently. So that's a clear advantage. The level of customization is shown here, which I explained there. In driving, you will have to have all the pallets of same SKUs, whereas each level can have a different SKU in terms of shuttle racking. A simple calculation here, we have taken 20 bays and across rather 15 bays, and you have got 20 pallet positions, and we have considered 4 levels. Means this is a plan, and so you are seeing from the top side, top view, it's a top view, and in case we have 4 levels from bottom to top, here we have 20 into 4, 80 pallet positions, and across we have got 1200 pallet positions here. Consider it to be a drive-in racking, we would be able to store only 15 SKUs, each bay having only one SKU across all 4 levels. So the number of variety will be only 15 as mentioned here. Now, if we come to the same shuttle racking of the same plan, in place of this 15 SKUs, each level can house 4 SKUs. Each level can house 1 SKU, and hence 4 levels in each bay can house 4 SKUs, and hence 15 into 4, it can house 60 SKUs. Versus 15 SKUs in drive-in, shuttle can house 60 SKUs, and hence it can support more varieties with the same density. It supports first in, first out operation, which cannot be easily done in a drive-in racking. Higher throughput, the throughput would be double that of drive-in racking, because in drive-in racking, the material handling equipment has to go inside, pick up and bring it out very carefully. Here it would be double the throughput. The throughput is very high. 20 pallets per hour can be done by a shuttle, where only 10 pallets per hour can be done in a drive-in system. Maximum utilization of pallet positions. Honeycombing effect would not be there. All vacant positions can be filled and identified by a shuttle and can be used completely. Counting of pallets can be done here using the shuttle, whereas in drive-in we need to do it manually only. Minimum usage of manpower and material handling equipment in terms of shuttle racking, whereas it's higher in terms of drive-in racking, because the material handling equipment has to get inside the system. And maximum utilization of building height is up to 12 meters here, and in drive-in it can go up to 10 meters. These are some of the advantages shuttle has over the drive-in. So that brings us to the end of the presentation on shuttle racking system and its advantages in a denser storage system where space is very critical in today's time. Thank you for your time, and we are open to your questions.
Thank you, Shiva sir, for this very insightful session. And as you likely said, space is of utmost important at this time. So I'm sure that the audience is now well aware of how a shuttle racking and a drive-in racking system will help them manage their space, warehouse space, sir. So we have a few questions, sir. I'll ask them one by one until we have time at least. And then maybe you and Mr. Nag can help us answer these questions, sir.
Yeah, we have Nagendran, who is heading our innovation center and design, and he's also available to answer the questions. Yeah.
Great, great. So the first question that we have received is, could you elaborate on the safety features and mechanism incorporated into the shuttle racking pallet systems to prevent accidents or damage? I think you've covered this mostly in your slides, but if you can just maybe a couple of critical points with related to this, sir.
Yeah, so some of the things are one, it is very safe because the travel inside the system is done by a shuttle, which goes in a very methodical way. It travels through the channel. The channel is there to guide the shuttle to go into the till the end of the bay, place the product or retrieve the product, and the speed of the shuttle also can be adjusted according to the product, whatever we are choosing to bring out or to place inside. Another thing is, whenever you have different sizes of products, sometimes it may slightly be bulkier than than the pallet. Even then, the space between pallets can be managed using the shuttle system by programming it accordingly. So there are much more features. In emergency situations, you have emergency stop button, and so all these features, there are a host of features other than even I explained, which can be programmed in a shuttle, and it's very safe. And when I talk about safety, it is not only safety for the goods, it's safety for the entire structure, the storage structure, which is very important. And in case of a drive-in system where a metal and equipment goes inside, even a accidental touch on a column could cost us heavily. So to that
Correct.
extent, shuttle helps us out.
Great, great. I think that answers the question. So the next question is, are there any weight or size limitations in shuttle racking system? I think they are referring to the weight of the pallet, I think.
Yeah, so as
Weight and size of the
I
pallets.
mentioned, 1,500 to 2,000 kilos is what is prescribed. Usually 1,500 kilos can be carried, programmable up to 2,000 kilograms. That's the
Okay,
weight. If you ask about the shuttle weight, the shuttle weighs about 250 to 220, 230 kilograms.
okay,
230
all right,
kilograms.
all right. So the next question is, what kind of maintenance or regular inspections are recommended for shuttle pallet tracking? Are there any specific guidelines or best practices to ensure longevity and optimal performance?
So there are quite a bit of instructions as to how it has to be operated. There's a list of things, whatever do's and don'ts using a shuttle. If we follow those list of instructions properly, then the longevity of the shuttle would be in place. Um, there are adequate measures, safety measures in shuttle itself to give an alarm as to in case there is any dust or if there is any malfunctioning or anything. Uh, any spillage of oil, liquids, all these to be avoided on the shuttle system as far as possible. Uh, and
Right.
more than this, a regular audit, conducting a regular audit on a yearly basis will ensure that the shuttle system remains intact, the shuttle equipment remains intact.
Correct. Correct. Right. Correct. So the next question is, can shuttle racking system be provided with seismic zone modification? So basically, I think that seismic zones where some customers might require seismic zone modification, can shuttle racking be also provided with that?
You see, in a seismic area, it is for the racking system to be in a robust situation. The racking system comes with a lot of seismic seismic withstanding condition capabilities. The racking system can be made to withstand the seismic movements. So that way we can do seismic fitment. There's a special
Mhm.
treatment need to be given to the normal racking system that can be given, and it can be made seismic resistant racking system. Uh,
Okay. Okay.
in any case, yeah, that's
All right.
it's
All right.
on the it has got
It's
nothing to do with the shuttle. It has to do with the racking system, which can be
yeah, the
made.
actual racking. Yeah, correct. Correct. Got it, sir. Got it. So the next question is, in terms of flexibility and adaptability, how easily can shuttle pallet racking be reconfigured or expanded to accommodate changing storage needs or inventory fluctuations?
So, as I explained during my presentation, all types of SKUs can be used in a shuttle racking system across temperatures also, from plus 50 to minus 35 temperature variation we can be used, from
Mhm.
chemicals to pharmaceuticals to engineering products to food and beverages to um, fast-moving consumer durables across the sectors, engineering machines. Some of the pictures which I showed were a testimony to that. So
Correct.
it can be used for across the industrial requirements and capabilities. It is
Correct.
adjustable, and there's a lot of programmable facility also
Yeah.
using the Ethernet port where we can program the shuttle to handle it accordingly by giving space or adjusting to the pallet width or so on and so forth. So a lot
Correct.
of flexibility is offered.
Yeah, it's quite versatile in that sense, right? Right,
Yeah.
sir. So the next question is, can this also be used for vertically storing stacks of steel sheets or plates?
Shuttle system has got a dimension, and within that dimension, whatever it can house, it can take. Normally, a pallet size of 1,200 by 1,000 or 800 by 1,000 or something of that sort. Those are the, excuse me, those are the pallet sizes which will go onto a shuttle. Longer products, more than this, might not be possible to house in a shuttle system.
Okay, okay, okay. So the next question is there any additional light facility apart from flashlight in shuttle racking system, especially during night operations?
Yeah, we have got that flashlight is the one to identify the shuttle in night times. Excuse me, to identify the shuttle. So through the remote control, when you switch it on, then the light will flash and it will indicate where the shuttle is there. Through that, it can be easily identified. The light is adequate enough to identify the shuttle inside the racking
Okay,
system wherever it is.
right, right. So the next question is, how do you arrive at the number of shuttles required in the system?
So that depends on the type of throughput required by the organization. which is going for the shuttle racking system. Uh, Organizations like us who are into racking, we develop solution. At least from Godrej, we develop solution according to the requirement of the customer, understanding the needs and expectations of customer in terms of storage and retrieval. According to the storage and retrieval, the required throughput and the type of the material to be stored, the number of bays to be created, the number of levels to be created, and hence the number of shuttles. So it depends on all these things
Right.
to
Right.
arrive at the right number of shuttles.
Yeah. Yeah. I'm sure there are a lot of factors involved in identifying which
Yeah,
is the correct.
right.
Yeah. That's right. That's right. So the next question is, what is the average end-to-end cycle time using shuttle?
Um, can you elaborate the question end-to-end cycle time?
I think they
What do you
are
mean by?
asking about, I think the pallet throughput, but I'm not sure whether
I
maybe we need some more clarity on this question.
Yeah.
So we'll
If you are
get back
looking
to
at
this question. Yeah.
the hours of usage, 8 hours of usage is the one,
Okay. Okay.
uh, and
I
5 hours of battery service, battery
okay.
charging time, and then you can use it for 8 hours.
All right. All right. I think we'll contact whoever's requested this question. Maybe you can take a more correct answer then. So this I think last two questions, and I think then we can end this session. Sir, what are the potential challenges or limitations that organizations should be aware of when considering the implementation of shuttle pallet tracking systems?
See, one of the thing is that limitation is in terms of the variety. If it can't be as high as a selective pallet tracking, so in case you have higher selectivity, then shuttle would be a slight disadvantage. Rather, I would put it this way. If there are limited variety and there is a bigger lot size to be stored in 15, 20, 30 deep, then they should go for shuttle. And in today's scenario, shuttle system is adopted more and more because
Mhm.
biggest advantage rather than disadvantage, I would say it is an advantage wherein human operations are minimized, human errors are minimized, and it's a fatigueless operation which is getting carried out, and the same quality output from the time in the morning it starts off till the time of 8 hours, you're going to use that particular shuttle. So without a fatigue, without compromise in quality of retrieval and storage, ensuring the quality of goods, ensuring the racking system remains intact, it can
Mhm.
do a very good job of retrieving and storing, provided the variety is not as large as you want to be serviced through a selective pallet tracking system. I would put it this way.
All right, sir. All right. So, I think there's Mr. Abhishek has given the elaboration for the question he had asked earlier. I think he's asked is what is the average end-to-end cycle time using shuttle for retrieving one pallet? So basically, he's asking what is the average end-to-end cycle time for retrieving one pallet using shuttle system from G+5 racks?
So, as I said, the speed of the shuttle is more or less defined. You mentioned 35 meter per minute for a loaded one and 70 meters per minute for a free shuttle. So it depends on the number of deeps we go. The more deeper, to that extent it has to travel. The travel speed is going to remain the same, and it depends on how deep we want to design the system for. The lesser deep, it can be faster. So more deep, it would be to that extent, and we'll have to do that mathematics and see for ourselves basis the solution which we are designing. But the base numbers are 35 meter per minute for a loaded one and 70 meter per minute for a unloaded shuttle to travel. That's the speed of travel.
Correct.
I hope I
I think
answered the
you've
question.
answered. Yeah, I think you've answered the question elaborately. Sir, I think with that we can conclude this webinar. I think we have come to the end of the questions by the audience. Sir, first of all, let me thank you for giving time for this webinar. I'm sure that the kind of knowledge and the kind of insights that you have given is something which is very useful for anyone operating inside a warehouse, and I'm sure that the next time they plan any warehouse setup with racking, this will be in the back of the minds, and I'm sure that with the kind of space saving that any shuttle system or racking system or driving racking provides, this will be right there in the top of their mind to implement, sir. So I'm sure that this will be very useful for the audience. Once again, thank you very much for your time, and thank you for the audience for sparing their time as well for this particular webinar. We would request the audience to just provide your feedback on the link that we've published. It will help us in strengthening this webinar series, and I'm sure that there are suggestions of what topics do you want us to cover in the next webinars to come. So with this kind of feedback, it will just encourage us and will help us in grow and provide you that kind of right content as well, sir. So with that, Mr. Shiva, thank you so much for your time, and Mr. Nagendran, thank you so much for your insights as well. With that, we'd like to conclude this session, sir.
Yeah, pleasure is ours. And thanks for a wonderful interaction with a lot of good questions. Hope it helps all the participants. Thank
I'm
you
sure
all
it will,
for the
sir. I'm
time.
sure it will. Thank you
Thanks.
so much, sir. Thank you. Bye.
Thank you. Thank you all.